This is a video made to illustrate section 12.4, two-way analysis of variance. This is the illustration exercise on page 399. WARTA, the Warren Area Regional Transit Authority, is expanding bus service from the suburb of Starbreak into the central business district of Warren. There are 4 routes being considered from Starbreak to downtown Warren. The US 6 list shown here, via the West End, via the Hickory Street Bridge, and via Route 59. WARTA conducted several tests to determine whether there was a difference in the mean travel times along the 4 routes. Because there will be many different drivers, the test was set up so each driver drove along each of the 4 routes. Below is the travel time in minutes for each driver route combination. At the 5% significance level, is there a difference in the mean travel time along the 4 routes? If we remove the effect of the drivers, is there a difference in the mean travel time? So from the previous section, without the drivers, we just needed to do a data analysis single factor ANOVA and select the 4 routes. We select labels on the first row, alpha 0.05, in my output range, let me just put it here, I will have obtained this result. Between groups is the variation of the routes. Within groups is the variation from the error. The SSE that is called before. And then the MST calculated in the book was calculated by using the SS divided by degrees of freedom. And the MSE, the SS of the E, of the error, divided by degrees of freedom, 16, will obtain this. The ratio of these two MS give us the F statistic with a p-value of 0.09 and then the critical value of 334. That's from a previous section. Now here we need to introduce another variable, the drivers. Also, driving across these different 4 routes. So we need to now run what is called in the data analysis sequence. We go to ANOVA 2-factor without replication. Click OK. Now input the range and cover everything including the labels. Check labels. The alpha is 0.05 as indicated in the instructions and the output range. You click inside the cell, click here, let's say, and that's where you obtain the results. If you notice, my SS total, my source of variation from the total, is 229.2 or 229.2, 229.2. It is the same. However, I have now variation coming from the rows, from the columns, and again the error. The rows are the drivers, the columns are the different routes, and this is the error, or residual you can call it. If you take 229.2 and subtract this 2, you get the 36.7. Same as here, if you take the total variation and subtract between variation, then you get the within variation. Alright, but now we have, for the rows, if you see here above, we have 5 drivers and we have 4 routes. So the rows are the drivers. The degrees of freedom is number of drivers minus 1, or in your book is shown as B minus 1. The drivers in this case is called the block variable. And there is a way that you can, if you follow the instructions in the book, in formula 12.6, you can calculate this number here by using the corresponding formula shown on pages 400 and 401. But in Excel, you can obtain it directly. So you take the sum squares of the rows divided by the degrees of freedom, which are B minus 1, 5 drivers minus 1, 4, and you obtain the mean square of the rows, which is a variance measure coming from the rows. On the columns is the routes. 72.8, the sum of squares divided by the degrees of freedom. What are the degrees of freedom? Well, k minus 1. K is the number of routes. Minus 1, that is 4 minus 1 equals 3. And ms from the columns, the mean square coming from the columns, is just 72.8 divided by 3. That gives us 24.26. This is mean square of the columns, which is also a variance of the columns. And finally, we have the error, the sum square of the errors, 36.7, which is, if you notice, significantly less than what we had when we just had one factor. Now the error is much lower because we have variation coming from two sources. To take the 36.7 divided by the degrees of freedom of the error. What is the degrees of freedom of the error? In this case, it's just multiplying these two numbers. 4 times 3 equals 12. The general formula is b minus 1 times k minus 1, where b is the block variable and k is the number of block variables and k is the number in the treatment variable that is called in your textbook, or the columns. So take the sum squares divided by the degrees of freedom, that give us the MSE. Now the next step is, well, before I continue, notice that the total degrees of freedom is 19 here, the same as here was 19. The total degrees of freedom is always n minus 1, where n is the total number of numbers in the data set. We have 20 here, 5 drivers times 4 routes equals 20. 20 minus 1 equals 19. You could have used that also to figure out the number of degrees of freedom in the is for the error. If you knew 4 and 3 here, and you know that this total must be 19, 19 minus 7 must be equal to 12. Alright, so the next step is to calculate the F statistics. And we have to compare the F statistics to a critical value of F. Well, the F statistic is just the ratio of two variances, as you may recall. 29.92 divided by 3058. Again, the MST, or the MS from the rows, divided by the MSE. That gives us 978 for the rows. And then for the columns, take the MS for the columns, 2426 divided by 3058. That is equal to 793.4. So those are the two F statistics obtained for the rows and the columns. And the critical values are 326 and 349. And as you may see, the two F statistics are greater than the critical values. In other words, we had to reject the null hypothesis in each case. What is the null hypothesis? That the population means are equal. So in other words, we conclude that the population means are not equal for both the treatments or the routes and also for the drivers. And the p-values also show both of them are much lower than 0.05, indicating areas of rejection.